No speed tests, please.
What? Lee, can you close the door?
Nice.
Nice.
I wrote this
That's awesome.
during the talks. It's also a module.
Who's next?
Okay, so
Can you feed it any PNG image?
in theory, but no,
Okay.
I hard coded it.
That's very bright.
Oh gosh, that's pretty bright.
Can we, let's see.
We unbright that?
Yeah.
Hi, New York.
I'll, is that better?
Yeah.
Right.
Black is much darker than white.
Whoa. Okay. Oh, it should be a divider. Oh well. Hi, I'm Steven, or Novel on the internet. So something I've been thinking about, pardon me, I have a cold, is collaborative text editing. There's like a lot of things that do this right now, like Google Docs and Etherpad, but they tend to be centralized, and there's a lot of really cool peer-to-peer tech happening. A lot of it coming from this group, actually. So I've been doing a lot of research about this. I haven't really put code to paper yet, but I think I have some ideas about data structures and modules that I would use that I think would solve the big challenges in doing this. So I'm going to talk about those. So obviously there's a dependency on a central service with something like Google Docs or Etherpad. Actually, Google ended up buying the company that makes Etherpad, so I guess Google owns like all collaborative document stuff right now. And like making backups is usually kind of hard, tends to be tied into the service. And if you're not on the network, that's sort of like a really big problem. Offline editing with like pain-free like reconciliation without having to do like manual merges isn't really a thing. And as people being in Svalbard and traveling, poor intermittent internet is a pretty common thing. So the two big challenges I want to talk about are peer discovery, so finding other people who are editing the same document as you, so you can edit in real time. And the bigger problem is resolving edit conflicts, so that user A can work on a document offline for like a week, and then other users are working on it, and then this user returns and be able to have their changes integrated into the document in a deterministic manner that gives strong consistency for everyone. So WebRTC is the peer-to-peer tool of choice for the browser, but WebRTC has there's like this introduction handshake where peers need to exchange information. Peers are often behind like NATs or firewalls, so having some kind of middleman like introducer component is usually necessary in order for peers to find each other. So this is kind of inspired by Friends, which is a peer-to-peer Slack-like project. And so a new user would presumably have sort of a unique identifier for the document. My document, 123. There's something like Signal Hub, which is a module written by, I guess, Matthias. So this is the middleman. This is what lets peers, this relays the introduction and acknowledgement messages so that peers can establish connections. In some ways, this is kind of like a centralized dependency, but anyone can run a Signal Hub instance. I think Matthias was talking about a DHT-based peer introducing system. So there's a lot of possibilities in this space for peer discovery that aren't dependent on central services. This then forms a swarm of peers, and they can all presumably edit documents in real time. What about conflicts, though? So CRDTs, these are like conflict-free replicated data types or converging data types. And these have some really cool properties. So the two big things they give are strong eventual consistency and monotonicity. So strong eventual consistency means that you can get updates in any order, or potentially like with very large delays in between, and everyone will see the same thing. And also that monotonicity removes the necessity of rollbacks. So having to like see like text appear and then have it be like destroyed or changed based on feature changes. So some common like small data types that do this are add only counters, grow only sets, and remove once sets. Why an add only counter? So this, if you had a counter that you could add to and subtract from, then it wouldn't be. I was reading the Wikipedia on this morning. It's because it's, I guess it wouldn't be. Moving on. So rather than struggle with words, I'll keep going. So imagine there's a text document being edited by Alice and Bob. It has the text world. Alice performs a local operation where she inserts at position 0, hello. But Bob locally performs a delete, also on index 0, deleting 2 characters. So order of operations matters in this case. So if Alice goes first, you get hello world, but if Bob goes first, then you get, you get hello world, then Bob applies his delete, and you get hello world. But if you apply these operations in reverse, you get hello world. So in this case, this isn't really a CRDT because the ordering actually matters, and you end up with different documents. So how can you resolve this? So causal trees are a way of, instead of addressing letters by a numeric index, like index 0, index 5, which change over time, like the content of that changes over time as users add and remove text. So what if you had some sort of unique ID to reference each position? So instead of the document hey being 0, 1, 2, you could reference it with UBQ1, UBQ2, and UBQ3, and then have operations that operate on these. So that no matter how much text gets put in front of, like, say, the beginning of the document, UBQ1 always refers to that capital H character. So if I do an insertion, I might now, if I want to insert an S at position UBQ1, that would then give me this new ID, this insertion UBQ4, and inserting another character might give me UBQ5. So no matter what order all these operations get applied in, you always end up with the same result because you're not using a global index value. So you end up with this tree structure where the root forms these like the top level edits, and then any edits that are made relative to any other characters become children. But wait, what about 2 users racing to make a child of the same node? That sounds weird. So imagine you had a document, hell, and Alice wants to put an O at the end, Bob wants to put an A at the end. Who wins? Because depending on the order they're applied, the result is different. So if Alice applies it first, or Bob or other observers see them in different order, you're going to see different things. There's something called Lamport timestamps. So the big idea is that what if we just use wall clock time? That should work. So that won't work because time varies from computer to computer, different time zones, and users, I guess, can lie. So you end up with this wouldn't work because clocks vary too much. And if I applied 2 insertions within 1 second of a 1 second resolution, problem happens. Lamport timestamps are about having logical time versus wall clock time. The idea is that time only moves forward when an operation occurs, and the time change is always monotonic. so that you can't get the same timestamp more than once, and each operation is guaranteed a unique ID. So Alice might choose a random prefix locally, like JMB, and Bob chooses TRK, and they start their clocks at JMB 0 and TRK 0. So operations, doing insertions, you can see that that JMB value keeps on increasing by 1. And then when to insert something at the same location, then operations can be ordered by lexicographically by whatever that timestamp is, and then this gives you a deterministic ordering whenever there's conflict, so everyone will still see the same thing. Because you can't really fundamentally resolve the problem of two users wanting to insert text in the same place. The best you can do is give a result that's consistent. And I was kind of thoughts more about like how would you do like storage and sharing, IPFS and WebTorrent. Maybe you could use one of those to do snapshots or like incremental vision history as a way of sharing resulting documents, also in a decentralized manner. So yeah, these are my thoughts on this, and maybe I'll even get around to coding it at some point. So, thanks.
Cool. Is there a repo that we can like watch just to see it unfold?
Question is there a repo to follow? I'll share it if I do.
Cool.
Go to github.com/IPFS.
Cool. Awesome. Good.
No more questions?
Sweet. Yeah. Okay.